So today we'll be doing a problem that has to do with optimization with a constraint. Now, each of these problems has their own equation, but there are some general steps. First, you always draw a picture. After that, you find your objective, which is usually stated in the problem. Most of the time, it's find the dimensions that will minimize the cost of something, or find how to maximize the space with this amount of money, something like that. Next, you set up your objective equation. And then you also will find a constraint equation, which has to do, for this problem, for example, we're finding the surface area of a cylinder with the volume of a set amount. So your constraint equation would have to do with the amount of volume that can be used during this. And then you also solve your objective equation. So for this constraint equation, for this optimization with constraint equation problem, a craftswoman wants to make a cylindrical jewelry box that has a volume V equal to 40 cubic inches. She will make the base and sides with a metal that costs 20 cents per square inch. The lid of the box will be made with a metal with a more ornate finish, which costs 150 cents per square inch. What are the dimensions that minimize the cost of materials? So, right here, we see step 2 of solving an optimization with constraint problem. Our objective is to minimize costs. Now, for the picture, we're going to draw a cylindrical jewelry box. So, something along these lines. And we're told pretty much everything. So the base and the sides will cost 20 cents. However, the lid is going to cost 150 cents. So up here, 150. And then all the sides are 20. And then the base is also 20 cents. Now, we know that the surface area of a cylinder, so SA, is equal to 2 pi r squared plus 2 pi r h. Now, this part is for the lid, in our case, and the base. And this is for the sides. Now, because our base and our lid are going to cost two different amounts, we actually need to split this up. So surface area will equal pi r squared plus pi r squared plus 2 pi r h. Now we're going to input the values of each. So we're going to say this is our lid. So we put it 150 pi r squared. We'll say this is our base, so plus 20 pi r squared. And these are our two sides, so plus 20 times 2 pi r h. Now we can combine like terms. So this 150 and this 20 are the same because they are pi r squared. So we get 170 pi r squared. And then here we'll multiply the 20 with the 2 to get plus 40 pi r h. Now this is what is considered our objective equation. So objective equation. But if you remember, we also need a constraint equation. Now, like I said in the beginning, usually the word problem will give us what we're going to use in our constraint equation, and this is no different. Pretty much, our jewelry box can only have a volume, V, equal to 40 cubic inches. So 40 is our number. So we're going to have 40 equal whatever the volume of a cylinder is, which is pi r squared times h. So in constraint equations, we have to try to solve for a variable that we can put back in our objective equation. Normally, we don't want to solve for r here because it is squared, which means we'll have to take the square root, and we don't really want to do that. So in this case, we'll solve for h by dividing pi r squared on both sides, and end up getting h is equal to 40 over pi r squared. Okay, so with this, we can put this in for any h we see, and there's only one in this equation, and it's right there. So we'll plug that in to the objective equation. So once we put our constraint equation in our objective equation, this is what we get. However, this pi and r cancel with this pi and r because you're technically dividing them. So those go away, and you're left with only one r in the bottom. Now, 40 times 40 is 1600, so you get 170 pi r squared plus 1600 over r. Now, what you'll do is you take the derivative and you set it equal to 0. So this would become 340 pi r minus 1600 over r squared equal to 0. So you move the 1600 over r squared over pi r equal to 1600 over r squared. And then to be able to solve it, you multiply out this r squared on both sides, and you get 340 pi r cubed is equal to 1600. So divide this 340 pi on both sides to get the r by itself. You can get r cubed is equal to 1600 over 340 pi. So when you divide this number out, you end up getting 14.78 equal to r cubed. You take the cube root of both sides, and you end up getting r is equal to 2.45. However, you are not done. You need to put this 2.45 back into the constraint equation, and when you do, you get that h is equal to 2.12. So in the end, what minimizes costs is r is equal to 2.45 and h is equal to 2.12.